Okay, so following my last video, in this tutorial, I want to give you a sort of an introduction to the calculations using financial calculator and Excel. So I want to mention that this course is not calculation intensive. If you are not willing to buy a financial calculator using whatever financial calculator apps or Excel, that's totally fine. But I have to go over this because I know some of you are using this for sure. Uh, okay, so in your financial calculator, you want to realize that there are five primary function keys. The N is the number of period. The capital I over Y stands for the interest and yield. PV stands for the present value. This PMT is the annuity function key, indicating the multiple cash flows incurred every single investment period. Okay, so this FV is the future value. Let's take a look at one example to help you to visualize the idea. Okay, so given the present value of 2150, interest rate of 13%, what is the future value over next year, 11 years? Okay, so in this case, the present value is 2150. Oops, let me clear my, erase the memory of my calculator first. Okay, so 2150 negative is the present value. So the reason why I put a negative sign here is, well, it really depends upon the way you think. So, well, I consider this 2150 is going to be my outflow. I invest this amount today, and I will collect my future value back to my pocket, which is positive. So present value is negative, future value is positive. If you drop this negative sign, well, it's going to be negative on the future value. Okay. Now, the third thing is the interest rate. Remember, in the setup of the financial calculator, the interest rate it's already converted to the percentage scale, so you don't need to add a percentage sign. So 13, then you press interest rate, and then the investment period is going to be 11 years. So you press 11, and then capital N. Now you compute, you solve for the future value. So basically, you can see on the left corner, you have CPT, which is short for compute. Your future value is going to be 82, whoops, 82.47 Okay, so whenever you got a sort of a time value question, you really need to sort out the input in the first place, and then you have to realize how to work on this process. So basically, you sort out the number of period to be 11, interest at 13%. The present value is 2150. Now you have your future value 82.47. It's really a very straightforward process. In this course, you don't need to, you can skip those mathematical derivation. I don't even cover it. The idea is, as long as you can use whatever calculator or Excel, any platform to solve for this basic present future value relationship, it should be okay. Okay. Let's look at another example. So let's solve for the unknown number of years, given the present value of 550, interest rate of 10%, future value of 1488. Now you are asked to solve for the number of compounding period. Okay, so I want to remind you that if you do not erase the memory of your financial calculator, all the results will be rolled over to your next calculation. So after each calculation, you really need to clear the memory of the calculator. So basically what you need to do is press the second function, then press the FV, which is the clear time value of money. Okay, then use second, and then clear work. Anyhow, so in this case, you basically erase the memory of your calculator, so it's completely clean now. In the video from Wiley Plus, I don't think it clearly say that, so I want to emphasize that a little bit. So back to this question, given the present value of 550, you press, 550 negative, and that's your present value. Future value is 1488. That's your future value, and the rate is gonna be 10%. Now you compute your number of compounding periods. So it's 10.44. Okay, sorry, my mouse is too sensitive. Oops. So it's 10.44, right? It's very straightforward. Well, if you do not put the negative sign on the present value, what's going to happen is, let me show you. If you do positive on both the future and the present value, then there will be an error on the financial calculator. No matter it's on a calculator or Excel, that's always the case. You need to ensure there is a sign difference between the inflow and the outflow, okay? So in this video, I also want to show you how to work on this using the Excel functions, okay? Let's take a look at three very straightforward examples. Suppose you have, let me zoom a little bit. Suppose you are going to invest $1,000 today, and the rate of return is 5.5% per year on the annual basis. And what will be your future value at the end of year 7, okay? In other words, at the end of the 7th year, how much money you can collect back to your pocket. Okay, so in this case, your input PV is $1,000. Your rate of return is 5.5%, right? And the number of investment period is going to be 7. Now you are asked to solve for your future value. Okay, so this 3 is the set of your calculation inputs. Now in the Excel, you have a function called future value, FV. So if you put if you input the equal sign, it will trigger the Excel function environment. So FV will bring you to the setup that allows you to calculate the future value with inputs of rate, number of periods, payment, and the present value. In this case, you don't have multiple cash flows, so you don't need to worry about the payment. So in this case, your rate is 5.5%, comma, and 7 periods, and payment is 0. And now you have a negative present value, close parentheses. Now you have future value of 14.5468. Okay, easy enough. If you do that using your financial calculator, you should be able to get the same results. Let me show you real quick. So present value of $1,000, present value. And then you have 7 periods of in terms of your time frame, and the rate of 5.5 is converted already. Now solve for future value. Oops. Oops. What? 5.5% rate. Now you compute future. Oops. What's going on? Sorry. Let's just start over. I think the mouse is not very easy to use. So present value of 1,000, 7 periods, 5.5, and that is your rate. Now you compute future value. See, it's going to be identical with your Excel output. Okay. Now let's turn to a real quick exercise on the future value. Oh, sorry, a present value. Okay, so suppose you are you need 100,000 in 9 years. Okay, for whatever purposes, education or whatever. Okay, and the required rate of return or opportunity cost is 4.5% on the annual basis. How much you need to have today? Okay. Now, so in this case, your inputs include future value of $100,000, and the number of periods is going to be 9 years. Annual return I over y, it's just 4.5%. Okay, so now you want to solve for your present value. So in Excel, you can use the present value PV function, and the inputs include the rate, number of period, annuity component, and the future value. So the rate is given. In the payment, just leave 0 over there. Also, sorry, the second input is number of period. The third input is payment, which is 0. And the third input is future value. Okay, so now you have this amount is going to be your present value. Notice that it's inactive amount, which means the initial outlay. Okay, you need to invest this amount to get 100,000 in 9 years. Okay, it's just a sort of a reversed engineering process of the present value example. Let's take a look at an annuity example real quick. By annuity, I mean every single year there is a cash flow incurred. So in a numerical example like this, you need to, so you suppose you need $100,000 in 9 years, same with the last scenario, and the required rate of return is 4.5% on the annual basis. How much you need to invest or save at the end of every year. Okay, so notice that the wording is kind of different. In the first two examples, it's sort of a lump sum problem. You either have a one stream of cash flow at the beginning or end of the time frame. But now for the payment type of a problem, you have annuity, a stream of cash flows, just like your phone bill or apartment rent. You know, every month you have to pay your rent or bill, right? So that's a type of an example of annuity. So in this question, you have well, suppose you have you need $100,000 in 9 years. Your FV will be 100,000, and your required rate of return is 4.5%, same with the last problem, right? And the number of periods is going to be 9 years. So for payment, you just need to do equal PMT. Now, the payment environment is triggered. So the rate is 4.5%, and the number of period is 9, and the present value in this case is 0, and you have your future value. Okay, so every single year you need to deposit or invest $90 to $57 to ensure at the end of a ninth year you have $100,000. Again, you can see it's in red color, which is negative. That means it's a stream of outflow, cash flow. Okay, so yeah, that's pretty straightforward. It's a typical example of an annuity. Okay, so if you work it on the financial calculator, it's gonna be the same. Let me clear the time value and erase the memory. So you have 100,000 future value, okay, and 9 years, which is N, 4.5, and that is your rate. Now you compute your payment. See, it's identical. So I think with these 3 examples, you have an essential idea of time value calculation using both the Excel and the financial calculator. I hope these 3 examples largely complement the videos from the YD Plus. Well, of course, there are lots of complicated stories built on the time value calculation. Again, like I said, this course is not calculation intensive, and that's not the purpose of this class. If you are interested in this type of, in the detailed quant analysis, you are more than welcome to talk to me, okay? So that's all what I have in this video.